All right, guys, we're in the looping chapter. We missed a lecture last week. I had to be out of town, so we only posted one lecture last week. So I've posted the other lecture from the pair. So I believe that it got into looping a little bit, and now we're going to do more looping, and we're going to talk about generating random numbers. Random numbers are cool because you can write games and stuff like that. So, just to rehash, want to make sure that we know the difference between a while loop and a do loop, which you Python guys have never seen before, and a for loop, which has a different syntax than the Python folk are used to. And also the for loop does something special, which it can iterate through an array or a list just as easily as it can iterate through a series of numbers, which is actually true of Python, right? So, we know what a loop is. Allows repeated execution of a block of statements. If you wanted something that would print out 10,000 numbers in a row, you wouldn't want to copy and paste 10,000 print statements into your code. So in general, what you got is a header. And, well, maybe not a header. If it's a do loop, it's kind of a trailer. But you have a condition, and then you have a body, and then you probably need an update. So a loop tends to look like this. You know, often you will initialize something, and then you'll have a condition, and then you'll have a body, like that. Whatever you're doing, printing something, whatever. That's a while loop. I am pretty sure that by the time you get into this class, you know what a while loop looks like. So whatever, right? Int I is equal to 3 while I is greater than 0, right? This is only going to print 3, 2, and 1, whatever, you know. And then whatever kind of print statement we need to use, right, console.write or whatever, just print I, right, whatever. And then we have to update it. If you don't update the variable, it's an infinite loop. By the way, for maximum speed, not that C++ is the fastest of all possible languages. This is especially true in the, C++ is an incredibly fast language, C# is not. It's actually faster if you increment it with the prefix operator rather than the suffix operator. And I don't know if that's true of all compilers anymore, but this one requires fewer lookups into memory than if you do I++. And I don't know why. If the compiler's writing the code for it, maybe, I don't know why. You can get small performance increases by doing that rather than if you do I++. Now, if you're embedding that in the middle of an expression, you want to be careful, right? Because this means, right, x is equal to I++ plus 3 means something dramatically different than x is equal to plus I plus 3. They look the same, right? But if the plus precedes the I, if it's a prefix, then that's the very first thing that happens in the expression. If it's postfix, if it follows the I, then it's the very last thing that happens in the expression after the entire rest of the expression is calculated. So if you had this, I is equal to 10, and then you did x is equal to I plus 3. That looks kind of funny. But anyways, so it would add 3 to I, which is 13. So after this, x is equal to 13, and then it would increment I. So I would turn into, 11, because it started off at 10. However, if we did it this way with a prefix, I is equal to 10 plus I, well, that's the first thing that happens. So I immediately turns into 11. And then we add 3 to it. So x winds up being 14. And then I still winds up being 11. All right, I'm going to delete all that. So if you don't have the update, then it's likely to be an infinite loop. You can get out of an infinite loop with a break statement or return statement, if I is equal to 1, break, something like that. That would get it out of the loop, even if it was an infinite loop otherwise. Or if you did I is equal to 1 return, right, like that, then that would get it out of the loop. But in general, if you don't have an update, it's going to be an infinite loop. Now, I am fond of using break statements. I'm so fond of them that quite often I will write while true, which should be an infinite loop, and then blah, 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 if whatever, break. Right. That way I can avoid doing what's known as a priming read, things like that. Okay, so that's a while loop. Well, what you may not have seen before, depending on which languages you've seen, is a do loop. The do loop looks a little bit different. Looks like this. Do some stuff. And here's your body. And then here's your condition. And you have to put a semicolon here. This is like the only time where you use a semicolon inside of a loop, outside of a loop structure, right? Because if you put a semicolon here, that totally breaks it. Right? That makes it an infinite loop. Just like if you put if condition and you put a semicolon there, then that breaks the if statement so that, the body of the code is always executed no matter what. So, anyways, what this means is it does, well, and maybe we have an initializing, right? Initialize. You initialize your stuff, and then it immediately falls into the loop without a condition, and so it does the body, and then it does the while. So it performs the body before it does the check. A while loop performs the check before it does a body. So a while loop is known as a pretest. And by the way, so are for loops. But do loops are post-test. What's the actual big impact of that? Do loops, the body is always executed at least once. While loops, that's not true, right? If you did x is equal to 10 while x is equal to 0, right, it's not going to go in and do the body at all, right? Because this condition was false, just like an if statement. But in a do loop, it would happen, right? If we move the, if we make that a do, and we make that a while, x is equal to 0. It doesn't look like it, at first blush, it doesn't look like it's going to do anything, but it does. X is equal to 10. Oh, okay, I'm going to do my body now. That wasn't a question, it was a statement, right? And then, oh, now I check to see if it's equal to 0. Well, it's not, so I'm going to break out of the loop, right? It exits the loop. So it would do that at least once. I guess I shouldn't have deleted the other statement. I'm going to move this back to being a while loop and make some comments. Do loop, body is guaranteed to be executed once, even if the while condition is false. While loop, body is not guaranteed. If the condition is false, the body does not execute. So each execution is called an iteration. If you're counting from 1 to 10, that would be 10 iterations. If you're counting from 0 to 99, that's 100 iterations. What if you're not counting? Well, if you're not counting, then you may not be able to predict the number of iterations, right? If you open a file and then you're reading each line in and you're adding up the numbers that are in that line, it's very likely you don't know how many lines there are. It still has a number of iterations, you just don't know in advance. If you don't know in advance how many iterations there are going to be, then you probably want to use another structure other than a for loop, or at least a for counting loop. All right, so Boolean expression, true, loop body, false. Obviously, this is a while loop, even though it doesn't have the word while. Now, if you've taken my fundamentals programming class, you know I like to put the word while there anyways, just to make the stuff easier to read. If this was a post-test loop, the loop body would come before the structure. The loop body would come before the decision. Infinite loop is a loop that never ends. So you initialize the loop control variable, you test it, and then you alter it. The loop control variable is a variable that's initialized before entering the loop. It's tested in the while expression, and the body of the loop had better alter it. I called it an update in all my notes here. All right, well, I guess I only did it. know. Did I not put an update in there? All right, I skipped the update. Bad, very bad, right? Because otherwise, if you don't have an update in it, it's an infinite loop. So going back up to the top of my notes, the 3 steps of a while loop are initialize, body, and update. The 3 steps of a do loop, or you do the initialize, you do the body, and then you do the update. And when I say 3 things, the body counts as a thing, right? I mean, we're not counting it as one. That's right. That's like one, the first thing we do. That's the second thing we do, because it doesn't really matter whether the body or the update comes first in it. And, whoops, the condition was the second thing to do. And then the update was the third thing to do. All right, and so for a do loop, the initialization comes first, then the update, and then the body. No, then the condition. All right. So that's step 3. So the while loop does 3 things: init, condition, update. And then the do loop does 3 things: init, update, condition. And yeah, it probably has a body as well. Now you can skip important parts of those if you need to, or if it's unnecessary. If you don't need to initialize anything, well, that's okay. If you don't want to update it, well, that's okay, but there better be a break or a return to get out. So the while loop, the body is not guaranteed to be run. The do loop, the body is guaranteed to be executed once. We saw that with the flow chart, right? It doesn't do the loop body until the check has occurred, because it's a while statement. You can have an empty body, which is a loop with no statements. Why? I don't know. Incrementing is adding to the loop control variable. Decrementing is subtracting. You can just use plus plus or minus minus to increment or decrement. A definite loop or a counted loop is a loop where the number of iterations is predetermined. You're going to count from 1 to 100, right? X is equal to 1. Do, right? Let's do some stuff. Print X. Forgive me for not using console.writeLine. And then X plus plus, plus X if we're going to say, I want maximal speed. I really bet compilers nowadays compile it just so that they're of equal speed, but what do I know? I didn't write the compilers. While X is less than or equal to 100, right? That'll iterate 100 times. The number of iterations is known in advance. Kind of an alternate of that is, or your list or array data is known in advance so that you can use a for loop. But I'm going to kind of not put that there, because if your list or array data is known in advance, and you're probably going to use a for loop rather than a do loop. Okay, so that's a definite loop, and a definite loop can be written as a for loop or a while loop, right? Pretty much almost every loop. And as a matter of fact, I'll make a generic statement. Any loop can be written with any one of these keywords. It just takes more to set it up sometimes, right? Like if you want to write a loop if you decide I hate do loops and you want to write it as a while loop, you can figure out a way of doing that. You better be able to figure a way out of doing that, because not all languages like Python have do loops. I'm not going to show you an example of that. You just pick the one that feels right. So we'll go over some guidelines based on what I mean by feels right in just a minute. So an indefinite loop. The loop control variable is not altered by arithmetic, but is instead altered by user input. So you don't really know how many times it's going to run. Could be running through a file, and when it hits the EOF, it's going to stop. Well, that is user input of a form, and something else generated the file. Or you're asking the user, right? What is the test score, or -1 to exit, that kind of thing. So a signal value is one where the user is asked, do you want to stop the loop? Now that's a form of indefinite loop, and I don't know why they list it, as being equal. I would tab that over, right, like that, because this is a form of input, just like that. I guess they're saying because you could have an indefinite loop. I'm not going to ask the difference between an indefinite loop and a sentinel value, because in my opinion, a sentinel value is an indefinite loop, even though they're wording it very precisely here that an indefinite loop responds to a loop control variable. But honestly, so does a sentinel value. So this code right here, not that we ever look at these very carefully when we're doing the lecture. Do you want to see your balance? Y or N? And then we do some input string. We convert the string to a character. And then while the response is equal to Y, we check. We get their bank balance. And then we calculate the interest rate. Do you want to see next year's balance? Yeah, if we do, they will type in a yes. So we have another read line here. And then we convert it to a character here. This is a while loop, so it's a pretest. So that means that they did a read line here before we went even into the loop. This would be probably a good use for a do loop, right? You could just come in here, you could display the balance, and then you could ask them, do you wish to see next year's balance? But whatever. You see how this is set up. We have an initialization, we have a condition, we do some form of update, and then we ask again. And so this is kind of a sentinel value kind of thing. It's actually not so much a sentinel value as what's known as user query. We are directly asking them, do you want to see next year's balance? I'm going to put that as 3 kinds of loop terminations. You can have counting loops, you can have sentinel values, and then you could have user query. Do you wish to continue? Y/N. I'm confused. Did we start class an hour early?
30 minutes ago.
Okay.
I was wondering why you did. I guess I threw you off. I'm sorry.
No. And so a sentinel value can be a little bit more complicated than just asking the user for it, right? It could be reading from a file and then the end of file marker, or the condition that you run out of data could be considered a sentinel value. So for loop, used to create definite loops. But as I said, any kind of loop can be written with any one of these keywords. You indicate the starting value for the loop counter, for the loop control variable. Then you test the condition, and then the body is executed, but the header also alters the loop control variable, which is known as step value. So the header actually dictates the initialization, the testing, and the updating. So in the while loop, we did the initialization above, and then we had a test condition, and then inside the braces, we had an update. Well, in this one, they're all specified in the same place. For integer x is equal to 0, and let's do the same kind of loop that we did where we're counting from 1 to 100. X is equal to 1, x is less than equal to 100, x plus plus, right? And then we're going to print out x. So about right. Fine. X. Right? Like that. We don't need to put an update because it's handled here. We've already added the update condition. which the textbook notes is also known as a step. So it starts off at 1, it performs the check, and oh, by the way, if this is false, it wouldn't go into the for loop. This is a pretest loop, just like a while loop. So if that was false, it wouldn't go into the loop. And then it updates. Nope. It does the initialization, it does the condition, then it executes the body of the loop, and then it does the update. A little bit odd, right? Because you would think that this means, maybe you would think that it means that the update happens before the body. You just got to remember, first thing that happens, second thing that happens, third thing that happens, fourth thing that happens. So for the init, the comparison, the condition, the update, and then the body. Now there's another version of the for loop known as a for each loop. And if you've taken Java, you've seen for each loops, but it didn't actually use the keyword each. And this one, it actually has the keyword each, so it's even easier to read. You know it's a different thing. We're not going to have use to talk about for each, though, until we talk about arrays in the next chapter, so we're not going to talk about for each. Just trust that there's another one. So, this is considered a definite loop, because the syntax is geared for counting, right? It doesn't have to be used for counting. The condition could, you could be doing something else other up here. You could open a file in that statement. You could check to see if the file into whatever, into file was checked. You could read from here. Or you can actually leave any of these parts off. It's about time to go ahead and crank up our code to play with for loops. Maybe we'll do one of each loop and then we'll be done with it. I know we did while loops in the last lecture, so I'm not going to spend a lot of time working on that. We may as well just make this a console app for ease of use. So I'll race you. I launch Visual Studio, see if you beat me. If not, pause the recording. Lecture J.
So you want us to just turn the I separately?
Yeah. You have goofed up. I need to unlock page for everybody. But this is definitely lecture I.
This is I that we're doing now.
Right, we're doing I now.
H is the one that we'll do that on our own.
Right, right. H is the one that y'all are gonna do on your own. Let me unlock it. Sorry to waste your time. I should pause the recording. So that was H, but we're starting I. All right, so I'm going to call this one the lecture I. All righty. So let's do a simple while loop. Let's print out the squares and the cubes of the numbers between 1 and 100, something like that. So we're going to initialize x to 1 while x is less than or equal to 100. Put a semicolon. That was dumb. Okay. And then let's print out x and its square and its cube. You know what? I'm going to do this. Int y is equal to x times x, comma, z is equal to x times x times x. Just have those numbers already arranged. I don't appreciate the fact that it spaced it out like that, So I'm gonna delete the spaces, you don't have to. Alrighty, so console dot write line. Sorry guys, I checked something, so I paused the recorder. Hopefully screen's about in the left position where it was before. One thing I want to do is just add my end while comment there. And then I want to add my console.read key down at the bottom before I finish, just so that, you know, when I run it, it'll stop. All right, let's print this value out, but let's print them in columns. We could just use tab, but we're going to be awesome and use the formatting. So console.writeLine. Whoa. Curly brace. We want to print out the first parameter, and it's going to be 10y, but I want it to be left justified, so I'm going to do that. And then close brace, and maybe a space. And then I want the second parameter, second value, second placeholder to be the same. Although really the squares and the cubes would need to be wider, right? So if this is just counting from 1 to 100, do we really need 10 columns for it? Probably not.
5.
Yeah, so I'm going to make that 5. And then for this one, you know, what's 100 squared? It's 10,000, so, you know, maybe make it 7 wide. And then let's make the third one 9 wide. And then close quote, and let's print out our variables. I'm going to go to the next line just because they're getting hard to see. X comma Y comma Z. Now I better update X. Plus X. I wonder what plus X plus. Would that increment it by 2?
Maybe you can compile later. I think I've done that before.
I want to see if that's a compilation error. Yeah.
Yeah.
Technically it ought to work, but nah. Okay. So when this runs, hopefully it will print out all the numbers. Yep. You know, between 1 and 100, their squares and their cubes. And what if we wanted to put a cute little column header, right? We could. We could print out some dashes up here, and we could print out, you know, some column headers up at the top. Square and cube. Why don't we do that just for funsies? I'm going to grab this stuff. I'm going to come up here. I just copied it. I'm going to paste it here. But instead of printing out X, Y, and Z, I'm going to print out num, and then square. Unfortunately, that's 6 characters wide, and I only reserved, yeah, I reserved 7, so that's good. And then cube there. That'll be prettier. I'm going to change the condition, though, just to print it down to 10. That's easier to see, right? Keep it all on one screen. So I just changed that. You see what I did, though? I just kept the same formatting string, but I'm printing strings rather than numbers. And for those of y'all who are familiar with the percent, you know, syntax, where you're printing out, you know, %s or %f or %d, it's kind of nice to not have to be able to specify, right, what kind of data type it is. So whether it was an int or a string, I didn't have to change the format. I like that. All right, so the number, the square, and the cube. Cool deal. Now we know how to write a while loop, right? You probably already knew. Let's do a do loop. Doesn't need to be that complicated. Let's print all of the even numbers between, right, 20 and 2. So again, I'm going to initialize something. X is equal to 20. That's my starting point. And let's do some stuff. Let's print out X. Console.writeLine X.
CW tab is going to help you so much. It's become
Does
like
it
that.
expand that? CW
Tab.
tab. Wow. Okay, my life has changed.
Yeah, that changed my life.
So, if you want to write console.writeLine, how about just CW tab? No, that does the same.
Yeah, there's no
yeah.
right.
Okay,
It's just
so
right.
anyways, if you want to type it out and let it fill it in for you. This is awesome. Type in CWW, tab, and it fills it out. That's pretty dang cool. Now can I just put X there, or do I have to put a formatting string? Nope, that'll work. But it's giving me an error down here just because I haven't finished my syntax. I'd better perform an update. X++, ++x. Really trying to train myself to do that. While x is greater than or equal to, now I've made a serious mistake. I said I wanted to count down rather than count up. So instead of x or ++x, that would count up, I'm going to make it x minus equals 2. Right, like that. X minus equals 2. Subtract 2 from it. The other way you could do it is just to decrement it by 1, but then use an if statement to make sure it was evenly divisible by 2 or not. But we're awesome. We're going to actually modify our loop control variable by the specified amount. So this should print from 20 down to 2, even numbers only. And that seems to be the case. 20 down to 2. All right, let's do a for loop. Let's make a for loop that'll print the numbers from 10 to 20 doubled, right? And so, 10 plus 10 equals 20. 20 plus 20 equals 40, stuff like that. So for, now I could just reuse x and not put int there. As a matter of fact, I might consider that a syntax error. C++ would not. This language probably will. So I'm going to use a different variable just to demonstrate that syntax. You can create your variable inside the syntax of the for loop, in the header of the for loop. So int y is equal to, let's start it off at 0. And let's go up to 10. So int y is equal to 0, keep running while y is less than or equal to 10. And then y plus, yeah, let's just do it by ones. We don't need to put an update down here because the update will be performed automatically after the body executes. All right, so we're going to do this. Console.writeLine. Oh, now I'm going to do it the fast way. CW, tab. Oh, that is so cool.
I just accidentally discovered for tab. So
Yeah.
I might want to try that.
So F tab or for
F-O-R
tab.
tab.
All right, so for tab. Whoa. You see what happened there? It created the entire for loop. All right, I'm never using Java again. All right, so here we go. We're going to write it out, but what are we going to write? Now I'm going to put my write line on the next line. Don't bother unless you just want to. Okay, so placeholder 0, and I want it to be like 3 wide. Into placeholder. Plus placeholder 1, comma, minus 3, just so that those two things will be put together, as close as possible. End placeholder equals one more placeholder. Let's make it like 4 wide. But let's do a minus. Whoops. So the second parameter, I want it to be left justified, and I want it to be 4 wide. Just because if we were printing out, 50 plus 50, that would wind up being an extra digit wide. All right, so that's my formatting string. So I close my formatting string, and I put a quote and a comma there. And now let's print out y, comma y, because we're adding y to y. And what is our result? Y plus y. That look a little silly? Yeah, it does. But this time I didn't calculate the values in advance. Right? I just printed them there. All right. And so it says 0 plus 0 equals 0, 0 plus 1 equals 2, 0 plus 2 is equal to 4, and so on. For our particular purposes, we could make this string just a little bit narrower, stuff like that. But let's leave it alone. Now I want it to look awesome. So I'm going to go, and instead of making this 3 wide, I'm just going to make that 2 wide, because all we're doing is counting from 1 to 10. So, we need a maximum 2 digits. Same for that one. And honestly, if we're gonna do that, we don't even need to specify a width. We could just let justify and it would all be good, but there's nothing wrong with specifying the width, so I'm just gonna leave that as is. Alright. I'm so impressed with myself. But wouldn't it, I don't know. Would it look better if I justified or left justified? Yeah, I'm gonna leave it alone. Okay. Alright, we know everything there is to know about loops until we start talking about arrays and lists and things. Let's see if the PowerPoint agrees. So the section of the loop. You initialize your variable in the for loop, the first parameter of the loop header. If you create a variable in there, that variable ceases to exist when the loop ends. So if I come down here and I try to print out y, or do something with it, like x is equal to y, it's giving me grief because y doesn't even exist at this point, right? It disappeared. If you declare a variable here, it disappears when it falls out of scope, when it's no longer between the braces. All right, so while we're on the topic of for loops, I want to show you something else. Let's say x is equal to 10. For, and I'm not going to even initialize x. I don't know why. I'm just not going to. As a matter of fact, I'm not going to even initialize it there. I'm just going to use whatever value was there in the past, right? And then my condition, though, is going to be keep going as long as x is greater than or equal to 0. And each time we iterate, countdown, right? So whatever x was, we're going to start there because we didn't reset it. We didn't give it a new value. So you're allowed to leave these things out. Console dot, right line, whatever. And I did it again. I'm going to have to train myself to type it.
Once you get used to it, you'll be doing it automatically.
Yeah. And then I'll be doing it in the Java editors and it won't happen and I'll cry. All right. So that would work. I honestly don't remember where x started, but I mean what its last value was. We'll find out. Oh, I guess it was already at 0. Okay, fine. I will initialize it to something. So it counted down. What if I left this part off? I could do that. I still have to have some kind of break condition, right? So if parentheses x is equal to 0, hit break. All right. So what if I feel like leaving this one off? I could do that. Let's put minus minus right there inside our right line condition. Now personally, I dislike updating my variable at the same time that I'm using it. But a lot of C-style programmers love to do that. So, just showing you the syntax. Alrighty.
Are the semicolons inside the parentheses necessary at this point?
Are these necessary at this point? Yes. Okay. But you're already familiar with my usage of while true. At this point, there's absolutely no difference between doing for, with all the loops empty, the conditions empty. And would it be reasonable to write this loop like that? I mean, we went to more trouble than it was worth, honestly. But there may be specialty cases, There may be specialty cases where you want to use the for loop syntax, but you want to leave some part of that off. And in my professional career, there have been times when I did that. It just seemed to look clean. But that's always your guiding, right? Because just like I said, you can write any one of these loops using any one of these syntaxes if you're careful enough. Just choose the one that looks the cleanest, the easiest to implement, and then the easiest to understand if another person comes up. Is this easiest to understand? Well, it wasn't so terrible. Yeah, I don't like this. We're making that here. What if this condition was buried like in 100 lines of code, right? Just looking at it, and then, before we scroll down, we don't even know what the update's going to be or what the exit condition's going to be. So, that's tacky. Well, I'm going to leave it there, though, just so which defeats the purpose of having a for loop pretty much. You could just write it as a while loop. But, right, if we had our x++ there, you know, at least we know that the update is going to occur. Because my trick is always writing a while and then forgetting to update the variable at the bottom of the loop. So even if it was like that, maybe there's a reason for putting it there just to remind, you know, whatever. But yeah, I would not write this loop that way. But I do want you to remember that these things are optional as long as you handle them correctly. You better have some initial value, hopefully. You better have some kind of update, hopefully. You better have some kind of break in there, or else it's just going to be an infinite loop. So here we're talking about a do loop. We've already covered this. Feel free to read the slide. It enters the loop without the test, because it's a post-test loop. The check is done at the bottom, after the body has been executed. That's convenient if you know you want to perform the stuff at least one time. All right, an example of that. I'm not going to actually implement this fully. But you're right, we could do a console. I'm going to type CW and hit tab tab. I'm just going to do this for a blank line. In fact, I don't even have to fill that in. But then I want a do loop that's going to print, you know, 1 for fun, 2 to quit. Right. And then we could ask them for the input, right? So string s is equal to CR. No, that didn't work. I wonder if there's a console.read line shortcut. So, anyways, that's what we did. String s is equal to console.read line, and then we're going to do our if s is equal to quote 1, then we're going to print out fun. CW tab tab, quote, fun, end quote, in parentheses, in semicolon. That's enough, right? Because if they typed in 2, oh well, we need our while condition down here at the bottom. While, and here's the problem. I didn't initialize my variable before the loop. I did it inside the loop. So to actually get this to work, I'm going to have to move the initialization up above the loop condition. Or I could just put a break in there, but if I was going to put a break, I would have written it as a while. So string s. Now in this case, I don't actually have to initialize it. I just have to declare it. I don't mind initializing it. The NetBeans editor would complain that that was an unused value. I'm not sure this one does. Now, we can remove that declaration. There. Sorry about that, guys. Here's what I added. And I removed the word string there. And my condition is while s is not equal to quote to quote. Now, sure, I could have converted, you know, the input to an int or whatever, but just for the purposes of the example. All right. So this is a valid use for the do loop, right? To display a menu and then have some if statements or case statements, you know, case switches, switch case statements in order to handle it. I like that. I like that better than the priming read, which is what the textbook shows, where you put a priming read up here, you ask them what you want to do, then you go into the loop with a while loop, and then you print out what, you know, what they wanted based on it, and then you ask them again. I hate duplicate code. I hate printing out the write line and then doing the read line. All right, let's make sure it works now that I've been bragging about it. All right, 1 for fun, 2 to quit. 1, fun, fun. Tired of that. What if I choose something that's invalid? 3, just doesn't do anything. Okay. All right, 2, it quit. It'd be nice if I'd print some done message down at the bottom, but I didn't. All right, so about the last thing I want to do is talk about generating random numbers. Now here I am thinking that we're all the way through the chapter, but you know, we're only on slide 14 out of 21 or something like that. Only slide 4? No, wait. Yeah, 14. This is off the screen. Remember where I was. Let's just talk about do loops. Here's the syntax, the flowchart for a do loop, right? This is our body and then our check. Alright, when loops are nested, each pair contains an inner loop and an outer loop. The inner loop must be entirely contained within the outer loop. Loops cannot overlap. Let me stop here and I want to do the random number generation. I'm kind of interested in doing that. We're going to demonstrate a nested loop anyways, probably, maybe, inside the random number generator. I bet y'all remember from fundamentals how to write summation loops, right? If we wanted to add up all the numbers between 1 and 100, we would know how to do that. You would just have to declare a total, and then you would have a loop that would add to the total. How about for loops? For, tab, tab, I equals 0, I is less than 100, less than or equal, I plus plus, and inside our loop, let's add total to it. Total plus equals I. All right, and then we can print out the total. All right, next, we're going to talk about generating random numbers. Just like any other computing language you've used, these are not true random numbers. A true random number is one that you absolutely cannot predict. Just like if you dropped, you know, a die from 1,000 feet in the air, you wouldn't know which side it was going to land on. But these are generated programmatically from a starting seed value, which we can specify, which we don't need to, unlike the C++ language, where you actually have to specify your own seed value. And then each successive number in the series is generated based on the last value that it generated. So if you know the seed, then you know what numbers are going to come after it. So that's what's known as a pseudo-random number. But let's make some kind of thing that's going to add 3 dice together. And so to do that, we need the random class. We need an object, an instantiation of the random class. So random R&D equals new random. There. We haven't done a lot of instantiation of classes yet in this particular one, right? That's the class type. We know it's a class because that's an uppercase letter. And then that's the name of the object. That's a reference variable. It will hold the object created by the new keyword. And then again, the name of the class is repeated here. I'm going to type something just to remind myself. I'm going to type auto there. No. All right.
Var.
Pardon?
Are you thinking about var?
Oh, yeah, that's right. In this language, it is VAR. That will tell it to create a variable of whatever type this is. And I've said this before, I don't see the point. But anyways. So we're creating an object of type random. And this is our random number generator. And if you've taken Java, you remember a random number generator that after you did that, you have to add the import for it. But it's part of the default C# libraries, so we don't have to go up here and add a using statement in order to get it to work. All right, let's get some numbers. You already have an X, Y, and a Z here. Well, I'm going to call them A, B, and C. Int A, comma, B, comma, C. A is equal to R&D dot, and you see there's several choices here. There's next bytes, that's interesting. There's next double, and then there's toString. Returns a string that represents the current object. Well, everything has a toString, so that's not exciting. Next double will generate a random number between 0 and 1. Fractional number. might be fun to print that out, right? You know, you'd see sometimes 0.8702394, whatever. But I want to do next int. Next bytes is interesting. Fills the elements of an array with random numbers. How about next? Just dot next. So dot next parentheses. There's three different forms. Returns a non-negative random number. I know this text is too small for you to read, so I'm reading it to you. This version, if we don't provide any arguments, returns a non-negative random number. Well, we don't know how big it's going to be. All we know is that it's a random number. My prediction is that it's going to be between 1 and about 2 billion because that's the maximum value of A. Yeah, why not? Why not? Why not just leave that alone and print that out? All right, and then A is equal to RMD dot next parentheses. Let's see what the next version of it is. Max value. We can specify the max value. 50. Now that generates a random number between 0. Nope. Yeah. A non-negative random number. So this generates a random number between 0 and, let me remind myself if it's inclusive or not, less than the specified maximum. So this would generate a number between 0 and 49. You never know in a library whether this is going to be inclusive or not. I just taught a Python class where it was inclusive. You specified the upper range. In this language, we are specifying 1 past the upper range. All righty. Now, for our die, you know, you roll a cube and it generates a die, a value. Oh, why did I make that A? How about B is equal to R and D next? For a die, it's got 6 sides. It starts at 1. It ends at 6. So what are we going to make our limit? 7, right? So that we get a number between 1 and 6. But this, if we just do next parentheses 7, it's going to generate a number between 0 and 6. But we want it to start at 1. So C is equal to R and D dot next parentheses 1 comma 7. And I'm going to put a comment here that this is between 1 and 6. Then we could print those out, just for funsies. CW, tab. Remind me, can we just type A, comma, B, comma, C and have it magically print those out? No, I didn't think so. And I know we can't write A plus B plus C because it would just do the math. A dot toString plus B dot, this is stupid, right? ToString plus C dot ToString. Now, then I would want spaces between it, so I'm going to delete all that and just give it and use formatting, right? So, right line. If we're not specifying the values, I believe we can just do this, and it'll fill them in. So A, comma, B, comma, C.
Nope, not in this one. That's Python.
That's
Here
Python, huh?
It's really annoying. You have to put it in.
All right, so 1, 2, 3. There we go. There we go. All languages should be the same. Yeah,
That'd be
then,
nice.
then it wouldn't be different languages. Okay. So, anyways, we ran it. 1 for fun, 2 to quit. Let's quit. And then it printed out our random numbers, right? That's a large value because we didn't specify an upper range. You know, 9,600,000, whatever. So it could go up to 2 billion would be my guess. And then 2, and then 2. Those numbers just happen to equal. I do not believe that will be the same each time. I'm running it again. I'm choosing to quit again. Right, and then 41 and 6. So that third number should always be between 1 and 6. The second number should always be between 0 and, 49 because I told it to go up to 50. So we're going to write just a silly little thing that'll add up the 3 numbers of like rolling 3 dice, and if we get 3 1s, it's going to quit. And we're going to count how many times it took in order to roll 3 ones. So I'm just going to call that count. Int count is equal to 0. While, oh, I better reinitialize my variables as well. A equals B equals C equals 0. And apparently I've already got a variable called count, right? Oh, it's just telling me that it's never used. Fine, okay. And then while A plus B plus C is not equal to 3, right? Because if I roll 3 ones, that's what it's going to equal. Let's figure it out. A equals RND dot next, starting at 1, going up to but not including 7. And I'm just going to copy and paste that. B is equal to that. C is equal to that. And let's increment count. Count plus plus. Now we could make an if statement and all that, but I think it's okay to just flat out increment count because this is our first roll. And we will move count up to 1, and the first roll counts, right? So I think that's good enough. Do we want to print them out? Why not? Let's print out A plus B plus C. Console.write line parentheses rolled. Oh heck, let's just steal this console.write line. So I went up here to my last one, I copied it, I'm going to go down here and paste it. If you need to see it again, console.write line, parentheses, quote, placeholder 0, placeholder 1, placeholder 2, end quote, comma, A, comma, B, comma, C. And then after we're done, let's print out how many it took. Console.write line, I forgot to do it, write line, parentheses. It took placeholder 0 in placeholder iterations to get 3 ones. So end quote, comma, count, in parentheses, semicolon, like that. That's almost too much. That is definitely too much to fit on one page. I'm going to zoom out just a little bit for a moment, but you know what it's saying. It took 0 iteration or brace iterations to get 3 ones. I could shorten this. I could make that say 3 as a number, and then I could make this say 1s, but that's harder to read. All right. Make it whatever you want. That about fits. All right, let's do. And it should be a different number each time. I'm getting tired of this one for fun, two to quit business. All right, it took 83 times. We can scroll back and we can look at all the numbers. But the next time it's going to take a different number. Should. It took 529. So the first time we were lucky, right? The second time it took a lot longer. It took 45 that time. So this is kind of interest, right? This is just learning how to do this so that we can use random numbers in our assignments. Random numbers add some unpredictability, you know. We can simulate, dice games or things like that. So we could fill up arrays with random numbers so that when we sort them, we have some good data to sort, that kind of thing. All right. So we've demonstrated using a while loop. We've demonstrated using random numbers. a summation variable. And I was lazy and I didn't sum them up, right? But I could. Yeah, let's print out the average. And by the way, the average of numbers between 1 and 6, 1, 2, 3, 4, 5, 6, it's going to be right there between 3 and 4. So if you roll enough numbers, the average should be 3.5. Let's see how true that is. So, int sum is equal to 0. I just added that. Now down here, after we roll our 3 random numbers, sum equals sum plus equals, parentheses, a plus, whoa, access violation, a plus, oh come on, a plus b plus c, like that. And once we get down here, we could print out the average, which is just, we should declare sum as a double,
You can cast it.
but I could cast it. Right, so anyways, double average equals, you know, the sum divided by the count cast to a double. And I'm not going to bother to make sure the count is greater than 0 because we know it's greater than 0. We know that it's at least 1, even if it, you know, got perfect ones in the very first row. And we need to print that out. CW, tab, average equals, end quote, plus average.
Did you print the sum?
No, I didn't, because did I print the sum? I could. Why not?
Oh, I guess we don't need to.
But we don't
have the
really
average.
need the
That's
sum
right.
because this
Right.
is an indeterminate loop, but it's just of interest. So why don't we come up here, because that way we can eyeball it and make sure, right? So we're going to say sum equals, end quote, plus sum, and the average is equal to, print that. And this is going to be enough iterations that the average should be real close to 3.5, right? If you only roll like 3 times, you have no idea the average is going to be 3.5. Excuse me, the average is not going to be 3.5. Why do I say that? Because we're not generating numbers between 1 and 6. This sum is actually between 3 and 18. And so that's an average of about,
12, no, 10.
it's somewhere between 9 and 12. 10.5. It ought to be 10.5.
Yeah.
10.5. Okay. If you drew a graph of what the sum of 3 numbers is, you would find out that it's a bar shape, and that rolling, 3 1s is the least common, rolling 3 6s is the least common, but there's more than one way to roll, a 4, because you can get a 1 1 and a 2, or 1 2 and a 1, or a 1 3. Yeah. So anyways, it would be a bar graph, and it would be kind of fun to print out that bar graph, but we would have to store the results first, and that would probably take an array, or it would take a whole bunch of variables and if statements. Let's leave that idea alone. All right, I'm happy enough. We've demonstrated, calculating sums and averages several times, which honestly you already knew how to do, I'm pretty sure. We've demonstrated using while loops for a variety of purposes. We've demonstrated using the random class. I think we're about done. We're about done from your point? All right. Okay, so we'll go ahead and stop and upload this.
And if you have time, Microsoft has documentation on all of their available code snippets, because apparently there's lots of them. That's what they're called, the CW tab.
So what's that called?
A code snippet.
Okay, cool. So if we come up here and Visual Studio Code Snippets.
Yes.
Microsoft Visual Studio Code Snippets. Creating your own. Well, I don't want to create one. Obviously, I hit the wrong answer.
Try that one, the next one.
So snippets are what get expanded. So if you type try F, it gets expanded to try finally.
Yep.
Well, that was not so cool. That's still not a complete list. C# code snippet reference.
Yeah.
There we go. Pound sign if creates a pound sign if and an end if. That's for preprocessor directives. Attribute, okay. Checked creates a checked block. Class creates a class definition. CTOR creates a constructor. All these will make sense once we start talking about object oriented. CW, we were using that, console write line. Do, tab creates a do loop. Else, tab would create an else block. Enum, all right. For, tab, for each, tab. For R, oh, isn't this cute? For RR. For R, okay, just for R with two R's, tab. Created one that starts at a value and then subtracts one from it. And then, yeah, you see what it did. It just created the syntax, minus rather plus, and you would just have to be careful to modify, the condition and the initialization to what you really wanted. Neato. What other? If, indexer, invoke, iterator, lock, namespace, prop full, sim, struct, try, catch, try finally. So, not that we've talked about try catch, but try, tab, generates your try block, followed by your catch block. Oh, that is so cool. Alrighty. And we're done. Go ahead and upload this into Dropbox.